Hello dear students, welcome to Konar classes. In this session we are going to start the second topic of binomial theorem, that is the general and middle terms. Okay, so let's start. So dear students, if you recall that the expansion of a plus b power n, okay, a power b plus n, let me write it one, that is equal to nc0 into a power n into b power 0. In fact, I can write a power n minus 0 into b power 0 plus nc1 into a power n minus 1 into b power 1 plus nc2 into a power n minus 2 into b power 2 plus nc3 into a power n minus 3 into b power 3, and in that way it will continue, and then we will get a term in between, that is we define as r plus 1's term, that is equal to ncr into a power n minus r into b power r, plus again it will continue, and then we reach the last term, that is ncn into a power n minus n into b power n. In our previous sessions I explained in details about this expansion in details, but what we are going to discuss today is that the general term. If you notice, dear students, that nc0 a power n minus 0 into b power 0, that is the first term. nc1 into a power n minus 1 into b power 1, that is the second term. nc2 a power n minus 2 into b power 2 is the third term. In that way, if we proceed, what we get, dear students, that ncr a power n minus r into b power r, that becomes the r plus 1's term. Correct or not? So this is r plus 1's term. Okay, and that is what we call it as a general term. So r plus 1's term we generally denoted by t r plus 1, capital T r plus 1, or uppercase T r plus 1, or lowercase t lowercase t r plus 1. It is up to you. So let me write that uppercase T r plus 1. What is this? This is equal to ncr into a power n minus r into b power r. This term is known as the general term. You may have a question that, sir, why that r plus 1's term is the general term? If you look into the sequence and series, there we discuss the nth term is tn, the sum up to the first term as sn. There we didn't say that tn plus 1 or sn plus 1. Then why you are telling here that the general term is tr plus 1's term, not tr's term? That understanding is also important. Why? If you look into the rth term, the previous term, what it will be? It will be ncr minus 1 into a power n minus r plus 1 into b power r minus 1. So it will have r minus 1, here n minus r plus 1, b power r minus 1. That doesn't look good because it is a very little bit of complex terms. That is why, to eradicate that, to remove that if you notice into that r plus 1's term, it is simple, ncr into a power n minus r into b power r. In your future, when you see we are solving some question, suppose we need to find the 16th term. Sorry, suppose we need to find the 16th term, that is t16. So how we should write this one? Then we should write is that t15 plus 1. We will write that t15 plus 1, and then we will apply this formula based on the value of n. Correct? So this is the way we should proceed. Okay, so now let's look into the next point, that is the middle terms. Okay, that how we can work on the middle terms. Okay. So if you look into this entire expansion of a plus b power n, what we see, dear students, there are n plus 1 terms. In the entire expansion of a plus b power n, we see there are n plus 1 terms. Correct? Now which one is the middle term? In that expansion, which comes in the middle, that is known as the middle term. Now what I say just now, if you take a plus b power n, it has n plus 1 terms. Now if n is even, then n plus 1 become odd, and if n is odd, then n plus 1 become even. So now based on that, whether n is even or odd, the middle terms actually differ, and let us discuss on that. So let us take an example. So example is that, let us take that a plus b power 2, that is a plus b whole square, that is equal to a square plus 2ab plus b square. Now let's take a plus b whole cube, a plus b power 3, that is equal to a cube plus 3a square b plus 3a b square plus b cube. Now dear students, if you look into the middle term of this expansion, here the middle term is this one, this 2ab, and for that we no need to have any other previous knowledge, because we see there are 3 terms, so this is the middle term. And when the value of n is 2, now when the value of n is 3, then we see there are 4 terms in the expansion. If there are even number of terms, then how to find the middle term? Here it is the plural number, middle terms. Okay, which one is the middle terms? This one, that is 3a square b, and it is 3ab square. Okay, so these are the 2 middle terms. Okay, how to find those middle terms? Let's work on this in a generic fashion. So when we see that a plus b power n, when n is even number, then there is only one middle term. Okay, for example, that a plus b power 2 is even number, so only one middle term. Now if a plus b power n, if n is a odd number, then there are 2 middle terms. Now how to find those middle terms? Let's look into it. So first let's see that a plus b power n. A plus b power n, when n is even. Here n is even. If n is even, then as we just looked into, there is only one middle term, then which term will be the middle term? Then n by 2 plus 1th term will be the middle term. n by 2 plus 1th term will be the middle term. Okay, n by 2 plus 1th term is the middle term. Let's look into it. Here what is the value of n? Value of n is 2. So which term will be the middle term? 2 by 2 plus 1. 2 by 2 is 1, 1 plus 1 is 2. That is the second term which is there. Now let's look into if n is odd. N is odd. Then in this case, dear students, there are 2 middle terms. And what are those? The first one is that n plus 1 by 2. Okay, this term. And n plus 1 by 2 plus 1th term. These are the 2 middle terms. Okay, so let's look into it with this example. Let's take value of n equal to 3. That is odd. That means there are 2 middle terms. What are those? N plus 1 by 2. So n is 3. 3 plus 1 by 2, that is 4 by 2. That means second term, this one. And the next one is that n plus 1 by 2 plus 1. That means this is already 2. 2 plus 1, that is third term. So what we see, dear students, that in the expansion of a plus b power n, depending on the value of n, whether it is even or odd, there are middle terms, we decide accordingly. How? If the value of n is even, then there is only one middle term, and that term is the n by 2 plus 1th term. Okay. Now, if n is odd, then there are two middle terms. The first one is that n plus 1 by 2th term, and the second one is n plus 1 by 2 plus 1th term. So, there are two middle terms. Got it clear? Now, let's look into some questions, and you also work with me. Okay. So, let me write down the questions one by one and let us solve together. You please open your notebook and do along with me. Okay. Okay. So, let it be there, these middle terms, because you just started learning. Okay. So, you may need help from here. Okay. The first question. The first question here. The question is, find a if the 17th and 18th term and 18th term terms of the expansion two plus a power 50 are equal. Okay. So, the question is that in this expansion, that binomial expansion of 2 plus a power 50, there will be how many terms? 51 terms. Out of those 51 terms, according to the question, the 17th and 18th terms are equal. Okay. Then under that condition, we need to find the value of a. So, dear students, if you remember, in the expansion of a plus b power n, what is the general term? That is the tr plus 1th term is the general term. And what is that? That is equal to ncr into a power n minus r into b power r. That is the general term. So, now according to this question, according to this question, we see that T18 is equal to T17. T18 is the 18th term and T17 is the 17th term. According to the question, these two terms are equal. So, now how to compute this one? T18, that means T17 plus 1, that is equal to T17, that means T16 plus 1. Now, dear students, we know that tr plus 1 is equal to ncr into a power n minus r into b power r. So, for how we can find the value of T17 plus 1? So, what is the value of n here? N is 50. So, it should be 50 C17 into 2 power 50 minus 17 into 50 minus 17 into a power 17. Correct? That is the T17 plus 1, that is T18th term. This is equal to the value of T16 plus 1, that is equal to 50 C16 into 2 to the power 50 minus 16 into a to the power 16. Correct? Let me give a boundary here. Correct? Now, from this equation, all you need to find the value of a. So, how to find that one? So, here we can write is that that a17 by a16. So, from here what we get? A to the power 17, a power 17 divided by a power 16, that is equal to 50c16. So in the numerator it is 50c16 and in the denominator it is 50c17 into 2 to the power 50 minus 16, that is equal to 34. So 2 to the power 34 divided by 2 to the power 50 minus 17, that is 2 to the power 33. So 2 to the power 33. So what we get here, dear students? So from here we get a to the power 17 by a to the power 16, that is means it is a, because a is not equal to 0. That's why you are able to cancel it. Then what is 50c16, dear students? If we write, that is equal to 50 factorial divided by 16 factorial into 50 minus 16 factorial, that is 34 factorial. Correct? Now 50c17, that is equal to 50 factorial divided by 17 factorial into, so here you can write into 50 minus 17 factorial, that is 33 factorial. So that is equal to 33 factorial into 2 to the power 34 by 2 to the power 33, that is 2. Correct, dear students? So what we see, the 50 factorial and 50 factorial get cancelled. Correct. Now from here we get the value of a as, we get what? So this will go up and this will come down. This because, so what we get, 17 factorial into 33 factorial will go to the numerator. So 17 factorial into 33 factorial will go into the numerator, and denominator will get 16 factorial into 34 factorial. 16 factorial into 34 factorial into 2. Now how to expand? So we see this is equal to what we can write, dear students, in that permutation combination classes I discussed. 17 factorial and 16 factorial is there. So which one should we expand? 17 factorial. Because 17 factorial we can write 17 into 16 factorial. So that will eventually get cancelled with 16 factorial in the denominator. So 17 factorial we can write 17 into 16 factorial. Correct? Into between 33 factorial and 34 factorial, as 34 is greater than 33, so we should expand 34 factorial to get 34 into 33 factorial. So in the numerator as it is we write 33 factorial, and here I write 16 factorial into 34 into 33 factorial and into 2 as it is. Okay, let me make this border little lengthier. Okay, dear students, so now what we get, we see that 16 factorial got cancelled. This 33 factorial got cancelled. Then in the numerator we get 17 into 2, so, and denominator is 34, so 17 and 34 become 2, and these 2 and 2 got cancelled. So we get the value of a is equal to 1. So according to the question, we need to find the value of a. What is the value of a we get, dear students? So we get the value of a is equal to 1, subject to the condition that 17th and 18th term of the expansion of 2 plus a power 50 are equal. Okay. Now let's move to the next question. So both these things you should remember. This is the general term and this is the middle terms. Okay. The second question. The second question is, so that the middle term the middle term in the expansion of the middle term in the expansion of one plus x power 2n, 1 plus x power 2n is 1 into 3 into 5. In that way it will continue till 2n minus 1 divided by n factorial into 2 to the power n into x to the power n. Okay. So this is the question. The question here is that, so that the middle term in the expansion of 1 plus x power 2n is this expression, whatever you see. Now dear students, you tell me that how many middle term or middle terms will be there. We see that 1 plus x power 2n, 2n is what? 2n is an even number. If it is an even number, then there is only one middle term, and which is coming from here, right? So in this case it is not n, it is 2n. So which term will be the middle term? It should be 2n by 2 plus 1. So which term will be the middle term? So middle term will be the middle term will be, so let me write it properly, just a minute. So middle term is a, middle term is equal to, we can write, that is equal to 2n by 2 plus 1th term. Correct? We know in the expansion of a plus b power n, when n is even, the middle term is n by 2 plus 1th term. In context to our question, it is 1 plus x power 2n. So as 2n is even number, so its middle term should be 2n by 2. That means n actually plus 1th term. So this is equal to n plus 1th term. N plus 1th term, correct? So let me use a different color. So n plus 1th term. So how we write n plus 1th term? That is equal to capital T n plus 1. And we should use this formula. In this case n is 2n in context to the question, and r is n. So this is equal to what, dear students? So this is equal to 2n Cn into a power. What is a? A is 1. And so 1 power anything is 1. And what is b? B is x. X power n. Correct? So what we get, the n plus 1 term is that 2n Cn into x power n. Now what all we need to do, dear students, is that we need to show that this expression is equal to this expression, this one. That whatever you see, that this expression and this expression are same. That's all we need to do. And let's see how we can do this thing. Okay. So what is 2n? 2n Cn. 2n Cn is nothing but 2n factorial divided by n factorial into 2n minus n factorial. Correct or not? Into x to the power n. Now let us expand 2n factorial. If we expand, 2n minus n here. Okay. So 2n factorial, that is equal to what we can write? 2n into 2n minus 1 into 2n minus 2 into 2n minus 3. Okay. In that way it will continue till 5 into 4 into 3 into 2 into 1. Correct? The numerator. And denominator, what we get, dear students? The denominator we get n factorial into 2n minus n, that is n. So 2n minus n factorial become n factorial. And as we get it here, into x to the power n. Correct? So let's see how we can do this thing. Our target is what? Our target is to, so this is equal to this. That means 1 n factorial in the denominator must get cancelled in the numerator. How? Let's look into it. Okay. So dear students, so what we can do from here is that we can club together all these terms 2n, 2n minus 2, then 2n minus 4, then in that way 4 into 2 into 1. And the other terms, that is 2n minus 1, 2n minus 3, then 2n minus 5 up to 5, 3, 1 in the another one. So what I am saying, dear students, that so what I am saying that I draw a line here, then here I am writing 2n minus 1 into 2n minus 3 into 2n minus 5. In that way it continue till 5 into 3 into 1. Okay, so this is one part. The another part is, dear students, it is 2n into 2n minus 2. So let me write this thing, 2n into 2n minus 2 into 2n minus 4, correct? In that way it will continue till 4 into 2, correct? And in the denominator whatever we get, n factorial into n factorial, and as we get here into x to the power n, correct? Now if we see how many terms are there, 2n, 2n minus 2, 2n minus 4 and so on up to 2, there are n such terms. So from each of these we can take 2 common. So for n such terms we can take 2 common, and if we multiply them it will become 2 power n, correct or not? So what we get it here, dear students, so from here what we see, let me first draw this line which is the separator between numerator and denominator. So here we get 2n minus 1 into 2n minus 3 into 2n minus 5, in that way it will proceed. So into 5 into 3 into 1, and here we get 2 here, 2 here, 2 here in that till last term. Then what we will get? We will get 2 to the power n. So we get here 2 to the power n into what we left with after taking 2 to the power n common, n into n minus 1 into n minus 2 up to 1. So we get n into n minus 1 into n minus 2. In that way it continue till 2 into 1, correct? And into x to the power n. And in the denominator what we get, dear students? Denominator we get n factorial into n factorial, correct? Now let's look into this carefully. The 2n minus 1, 2n minus 3 up to 5 into 3 into 1 we already got. 2 to the power n we got. X to the power n we already got from long back. So in the denominator we get factorial n into factorial n. So what we see that n into n minus 1 into n minus 2, in that way till 1 is what? It is nothing but n factorial. So what we can write, as we do not have much space here in the board, so what I can write is that instead of entire thing I can just write n factorial, correct? We can write n factorial, and let me not write x to the power n there, so let me write it here x to the power n here, correct? In case any difficulty in understanding, you can pause the video, go back and look into it and you will get it. So then n factorial in the denominator and n factorial in the numerator got cancelled. Then what we left with? We left with 2n minus 1 into 2n minus 3 into up to 5 into 3 into 1 into 2 to the power n x to the power n by n factorial. That's what we need to prove, and we are done. So let's proceed to the next question, okay? And here is the question number 3, okay? The question is, find the coefficient of x to the power 6 into y to the power 3, x to the power 6 into y to the power 3 in the expansion of x plus 2y power 9. Okay. So let's see how to approach this type of question. Okay. So we need to find the coefficient of x to the power 6 into y to the power 3 in the expansion of x plus 2y power 9. Let's see how to do this thing. So to approach this question, dear students, okay, let us first find the r plus 1th term. Okay, so that is tr plus 1 in the expansion of x plus 2y power 9. Okay, so what will be the r plus 1th term? So that should be 9cr into x to the power 9 minus r into 2y to the power r. Correct? That is r plus 1th term, and in this case the value of n is equal to 9. So this is equal to what, dear students? So this is equal to, we can write this 2 power r, we can take it out, 2 power r into 9cr into x to the power 9 minus r into y to the power r. So according to the question, we need to find the coefficient of x to the power 6 into y to the power 3. That means what? From here we need to make this thing such that the value of r such that x power should be 6 and y power should be 3, and for that we need to take the value of r is equal to 3. Now if we take the value of r is equal to 3, okay, so then what we are going to get, this value become 2 to the power 3 into 9c3 into x to the power 9 minus 6, that is 3, into y to the power 9 minus 3 x to the power, let me write completely. Okay, let me write completely. So here it will be x to the power 9 minus 3 into y to the power 3. So when r equal to 3, so this become t3 plus 1. t3 plus 1 is nothing but 4. Okay, so that means it is the 4th term in the expansion. We get the term x to the power 6 into y to the power 3, but that is not the question. Question is that what is the coefficient? That means we need to find the value of this. That is the coefficient. So what it is, dear students? So this is equal to, we get 2 to the power 3 is nothing but 8 into 9c3. 9c3 is nothing but 9 factorial divided by 3 factorial into 9 minus 3 factorial, that is 6 factorial, into what we get, x to the power 6 into y to the power 3. So dear students, the coefficient, what is the coefficient? This is the relevant coefficient, correct or not? The coefficient of x to the power 6 into y to the power 3. So all we need to do is that find the value of this expression. So to find this value of this expression, so what we get, this is equal to 8 into 9 factorial and 6 factorial. So 9 factorial is more than 6 factorial. So 9 is more than 6, so we should expand 9 factorial. So what we get, 9 into 8 into 7 into 6 factorial divided by 3 factorial, we can write 3 into 2 into 6 factorial, correct? So this 6 factorial in the denominator and numerator get cancelled. The value of 3 and 9 here it cancels, so we get it 3. This 2 and 8 get cancelled, so we get 4. So what we get here, dear students? So we get the value as 8 into 3 into 4 into 7. So that is equal to 56 into 12. Okay, so 56 into 12, that we can find the value quickly. That is equal to 672, correct? And this is the answer to the question. So now, dear students, so let's move to the next question. Okay. And here is question number 4. Okay, so let me take it from my notebook. Question number 4. The second third and fourth terms in the binomial expansion in the binomial expansion x plus a power n are 240, 720 and 1080 respectively. Find x, a and n. Find x, a and n. Okay, so let's see. The second, third and fourth terms in the binomial expansion of x plus a power n. So second term means what, dear students? That is t2. t2 is equal to, we can write t1 plus 1. That is, we will apply the formula of tr plus 1. That means it is nc1 into, what is a? A is here x. So x power n minus 1 into, what is b? B is a. So, sorry, b is a. So what I can write here? Into a into a power 1, correct? And according to the question, this value is equal to 240. So this is 240, correct? Now what is t3, the third term? Third term means, t3 means this is t2 plus 1. If you apply this formula, okay, what we get? This is equal to nc2 into x power n minus 2 into a power 2. And according to the question, the third term is 720. So this is equal to 720, correct? Now the fourth term, that means that is t4. t4 equal to what, dear students? So that we can write t3 plus 1, that is equal to nc3, same formula here, into x power n minus 3 into a power 3, that is equal to 1080. So dear students, so what we see, there are three unknowns. What are the three unknowns? X, a and n. And in a very generic way, you can think that if there are three unknowns, you need to have three equations to find the values of those unknowns uniquely, correct? So here is one that nc1 into x to the power n minus 1 into a to the power 1 is equal to 240. Then nc2 into x to the power n minus 2 into a square equal to 720. And nc3 into x to the power n minus 3 into a to the power 3 is equal to 1080. From these three equations, we need to find the value of x, a and n. So let's see how we can do this thing. So we give, this is equation 1. This gives, this is, we give equation 2, and this we are giving equation 3. Now how to do? What you can do, dear students? So let me clean this portion. Okay. So we can divide both sides of the equation 1, both sides of the equation 2 divided by both sides of the equation 1. Correct? So that we can do. So if we do, then what we are going to do, what we are going to get, okay? So what I am saying is that both sides of the equation 2 divided by both sides of the equation 1. This implies, that means nc2 into x to the power n minus 2, nc2 into x to the power n minus 2 into a power 2 divided by nc1 into x to the power n minus 1 into a to the power 1, that is equal to 720 divided by 240. Correct or not? So what we are going to get here, dear students, so from here what we get, that x to the power n minus 2 and x to the power n minus 1 is x to the power n minus 2 in the numerator, x to the power n minus 1 in the denominator. So it become 1 by x, and here it is a. So what we get is that a square by a is a, and after adjusting x to the power n minus 2 divided by x to the power n minus 1, that become x. So we get a by x into what is nc2, dear students? nc2 is factorial n divided by factorial 2 into factorial n minus 2. Correct? And what is nc1, dear students? So that is equal to factorial n divided by factorial 1 into factorial n minus 1. Correct, no, dear students? So that is equal to 720 by 240, that is equal to 3. So you get 3. Now we see that n factorial and n factorial got cancelled. So in the numerator we will get n minus 1 factorial. So from here what we get, that a by x into, here in the numerator we get n minus 1 factorial, and in the denominator we get 2 factorial is 2 into n minus 2 factorial. Correct, dear students? So that is equal to 3. Now between n minus 1 and n minus 2, which one is larger? That n minus 1 is larger, so we should write n minus 1 factorial is equal to n minus 1 into n minus 2 factorial. Okay, so what we can write here, dear students? So this implies a by x into n minus 1 into n minus 2 factorial, n minus 2 factorial divided by 2 into n minus 2 factorial, that is equal to 3. So now n minus 2 factorial in the denominator and n minus 2 factorial in the numerator, that got cancelled. So what we get, dear students? So a by x equal to, we get 6 by n minus 1. So from here we get a by x is equal to 6, 2 into 3, 6 divided by n minus 1. Okay, so let me write it here, dear students. So a by x, what we get, in fact I can use a different color to write this one. So we get a by x is equal to 6 by n minus 1. Okay, so that we can give equation number 4. Correct? Now, dear students, if we divide both sides of the equation 3 divided by both sides of the equation 2, then also you will get a by x. Okay, if you look at very carefully, that powers are just in the difference of 1. So what I am saying, so let me do it here. So I am saying that both sides of the equation 3, both sides of the equation 3 divided by both sides of the equation 2, what it is going to give us. That means nc3 into x to the power n minus 3 into a to the power 3. That means nc3 into x to the power n minus 3 into a to the power 3 divided by nc2 into x to the power n minus 2 into a power 2 is equal to 1080 divided by 720. Correct? Okay, so now let's find it out, what we are going to get. So if we see, dear students, that that x to the power n minus 3 in the numerator, x to the power n minus 2 in the denominator. So that become 1 by x, and a cube by a square, that become a. So what we get it here, dear students, so we get a by x into numerator is nc3, that means n factorial divided by 3 factorial into n minus 3 factorial, correct? And in the denominator it is nc2, that means n factorial divided by 2 factorial into n minus 2 factorial. That is equal to 1080 by 720. So if we see this thing, so this will get cancelled. Okay, so here so here we can again cancel. So if we see that we can make it 108 by 72. So 72, what we can get is that 18, 4, if we cancel, if we divide it by 4, 27, then 9 we can divide 9 2 and 9 3. Okay, so that is equal to 3 by 2 after simplification, correct, dear students? So now what we get, dear students, that n factorial and n factorial will get cancelled. So from here what we are going to get, so this is equal to a by x into 2 factorial into n minus 2 factorial. So that is equal to what, dear students? So we get 2 factorial, that is 2 into n minus 2 factorial, n minus 2 factorial, and in the denominator it is 3 factorial. 3 factorial means 6 into n minus 3 factorial. Okay, so that is equal to 3 by 2. So now, dear students, between n minus 2 and n minus 3, n minus 2 is larger, n is obviously positive integer, hence we are saying so. So we can write n minus 2 factorial as n minus 2 into n minus 3 factorial. So what we are going to get, dear students, so this implies a by x into, and this 2 and 6 get cancelled, 3. So we write here is that n minus 2 into n minus 3 factorial divided by 3 into n minus 3 factorial, that is equal to 3 by 2. So now this n minus 3 factorial and n minus 3 factorial got cancelled. So what we get, dear students, from here a by x is equal to 9 by 2 into n minus 2. So from here what we get, a by x is equal to 9 by 2 into n minus 2. So let me write it here, dear students. So we get here a by x, we get a by x is equal to 9 by 2 into n minus 2. So that we give as equation number 5. Now, dear students, if we look into that equation number 4 and 5, we can equate that 6 by n minus 1 is equal to 9 by 2 into n minus 2, and that will give us the value of n. Once we get the value of n, we can find the value of a by x also from there, correct, and we can apply in any of these equations to get the value of the other one. So what we get from 4 and 5, that 6 by n minus 1 is equal to 9 by 2 into n minus 2. So that implies what? This implies if we multiply, cross multiply 12 into n minus 24, okay, 24, that is equal to 9 into n minus 9. So 12n minus 9n, that becomes 3n, 3n that becomes 5, 15. Okay, so from here we get the value of n is equal to 5. Okay, we get the value of n equal to 5. Now if we apply the value of n equal to 5, what is the value of a by x we are going to get, dear students? The value of a by x we are going to get 6 by 5 minus 1, 6 by 4, that is equal to 3 by 2. So now from equation 4, dear students, so what we are going to get, that a by x is equal to 6 by 5 minus 1, that is 4. That implies the value of a by x we are getting is that 3 by 2. Okay. Now from here we need to find the value of a and x. Now let's look into this one, that equation 1, dear students. So let me use a different color. Okay. So if we look into from equation number 1, what we are going to get, dear students? So from here, what is NC1? NC1 is n, we know, x to the power n minus 1 into x to the power n minus 1. Value of n is what? Value of n is 4. That will apply in the next step. Into a, that is equal to what, dear students? So that is equal to 240. Now what we can write, that x to the power n minus 1. So what is the value of a is equal to 3 by 2 into x. So let me write it here. The value of n is equal to 5. Okay, and x to the power, here it is 5 minus 1 is 4, and into a. What is a? From here we can write the value of a is equal to 3 by 2 into x. So let's write 3 by 2 into x, that is equal to 240. Correct, dear students? So what we get, dear students, from here is that we get, this implies x to the power 5, that is equal to 2 into 240 divided by 3 into 5. So we can cancel this one, 5 and 240, 48. Okay, so 3 and 48, that becomes 16. So what we get, x to the power 5 is equal to 32. So that implies x to the power 5 is equal to 32. Now we know, dear students, that 32 is 2 to the power 5. So that means x to the power 5 is equal to 2 to the power 5. So from the laws of indices, what we can say, that the value of x is equal to 2. Okay. So we get the value of n equal to 5, value of x is equal to 2. The moment we get the value of x is equal to 2, that we can apply here, and we get the value of a as 3 by 2 into 2, x is equal to 2. So that gives us the value of a is equal to 3. So dear students, we get the value of x as 2, the value of a as 3, and the value of n as 5. I hope you got a very clear understanding. Now let's proceed to the next question. All right. Okay, as I said, you also do along with me. Pause the video, make your understanding comfortable, and then proceed. Okay, so the next question, what I am going to write it here like this. Okay, so this will be question number 5. The question is, the coefficient of 3 consecutive terms, the coefficients of 3 consecutive terms of 3 consecutive terms in the expansion of 1 plus a power n, 1 plus a power n are in the ratio 1:7:42. So we need to find the value of n. Okay. So let's see how we can proceed to this one. Okay. Let me clean this portion of this board, dear students. So the coefficient of 3 consecutive terms. So how we can take these 3 consecutive terms? Let's look into it. Okay. So the best way of considering the 3 consecutive terms is that the tr minus 1, tr and tr plus 1. Okay. So that will give us that, it will help us to, cancel that, unknowns in a good manner, so that it will help us to find the solution quickly. So 3 consecutive terms. So the moment I hear this one, the 3 consecutive terms, so the terms we are taking as tr minus 1, then tr and tr plus 1. Okay. So what is tr minus 1, dear students? So that we can write is that t of r minus 2 plus 1. Why I am writing so? So that we can make it into this form. So that is equal to what, dear students? So that will be n c r minus 2 into a to the power r minus 2. Correct? A to the power r minus 2. I am not writing that 1 to the power n minus r minus 2, that will become 1, because this is the first term, no, 1. Okay. So that's why I am not writing. I hope you got it. So here we get the value of a as 1 and the value of b as a. Now 1 power anything is 1, that's why I am not writing a 1 to the power n minus r plus 2 actually. N minus r minus 2, that means n minus r plus 2. So now the tr, so what we can write tr, dear students? So we can write tr is equal to tr minus 1 plus 1, that is equal to nc r minus 1 into a to the power r minus 1. Correct? And in the similar manner, tr plus 1, that is quite simple, that is equal to ncr into a to the power r. Now, dear students, that according to the question, that a ratio of this is to this is to this is equal to 1 is to 7 is to 42. So what does it mean? What is the coefficients in this term? This is the coefficient. In the tr term, this is the coefficient, and in tr plus 1, this is the coefficients. So these 3 coefficients are in the ratio of 1 is to 7 is to 42. So what we get from this question is that nc r minus 2 is to nc r minus 1 is to ncr. Okay, that is equal to 1 is to 7 is to 42. Correct? And what you need to find, dear students? We need to find the value of n. Now, what we can say from here, nc r minus 2 and nc r minus 1. So what we can write that nc r minus 1 divided by nc r minus 2, that is equal to 7 by 1. Correct? ncr minus 1 by ncr minus 2 is equal to 7 by 1. So from here what we get, dear students? So from here we get ncr minus 1, that is equal to factorial factorial n divided by factorial r minus 1 into factorial n minus r minus 1, factorial n minus r minus 1. Okay, divided by nc r minus 2, so that means factorial n divided by factorial r minus 2 into factorial n minus r minus 2. Correct? So that is equal to 7. So from here what we get, dear students? So we see that these factorial n and factorial n got cancelled. So what we get from here, dear students? So this implies in the numerator we get r minus 2 factorial, okay, into n minus r plus 2 factorial, n minus r plus 2 factorial. divided by, in the denominator what we get, r minus 1 factorial, r minus 1 factorial into n minus r minus 1 within bracket r minus 1. That means if we open the bracket, it will be n minus r plus 1. So we get n minus r plus 1 factorial, that is equal to 7. Correct? Now what we get? Between r minus 2 and r minus 1, r minus 1 is larger because r is positive. So we can write r minus 1 factorial as r minus 1 into r minus 2 factorial. So we know why we writing this thing, because we know the n factorial is equal to n into n minus 1 factorial. So what we get, dear students, so r minus 2 factorial, and in denominator we write r minus 1 into r minus 2 factorial. Now let's look into this two. Between n minus r plus 2 and n minus r plus 1, n minus r plus 2 is larger. So what we should write? We should write n minus r plus 2 into n minus r plus 1 factorial divided by n minus r plus 1 factorial, that is equal to 7. Now dear students, r minus 2 factorial and r minus 2 factorial got cancelled. N minus r plus 1 factorial and n minus r plus 1 factorial got cancelled. Correct? Because all these terms are not equal to 0, hence we are able to cancel. Because it is not possible to have any integer whose factorial is 0. Okay. So from here what we get, dear students? So from here we get that n minus r plus 2 divided by r minus 1 is equal to 7. Correct? So from here what we get, dear students? So we get n minus r plus 2 is equal to 7r minus 7. So what we get here, dear students? From here we get the value of 6r. So from here let me write, that is, if we bring it to this one, so we get 8r. We get 8r is equal to n minus n plus 9 is equal to n plus 9. These r and 7r we bring into the one side, so that become 8r. Okay, then n plus 2 and plus 7, so n plus 9. So from here we get the value of r is equal to n plus 9 by 8. So from here we get the value of r is equal to n plus 9 by 8. Correct? So let us write somewhere. Okay, let me write in a different color here. So we get the value of r is equal to n plus 9 divided by 8. So let us give this as equation 1. Okay. Now dear students, what we are going to do is that I am going to take NCR by NCR minus 1 is equal to 42 by 7. Correct? Let's do. You also do along with me. Then you will see that you can utilize the time and you don't need to practice one again. Okay. So what I am saying, dear students, is that NCR divided by NCR minus 1, that is equal to 42 divided by 7. So what you can do, dear students? So from here what we can get is that NCR, what is NCR? It is factorial n divided by factorial r into factorial n minus r. And what is NCR minus 1, dear students? So it is factorial n divided by factorial r minus 1 into factorial n minus r minus 1. Correct? So this is equal to what we are going to get, here. So this is equal to 42 by 7 is equal to 6. So now dear students, this n factorial and n factorial got cancelled. So we can bring this to the numerator. So from here what we get, dear students, that r minus 1 factorial into n minus r minus 1 within bracket r minus 1. That means n minus r plus 1 factorial. So n minus r plus 1 factorial divided by r factorial into n minus r factorial, that is equal to 6. Now dear students, between r minus 1 and r is larger. So what we should do? We should expand r factorial. So what we should write in the numerator? R minus 1 factorial, and the denominator r into r minus 1 factorial. And between n minus r plus 1 and n minus r plus 1 is larger. So you should expand n minus r plus 1 factorial, that is equal to n minus r plus 1 into n minus r factorial. We know the fundamental, n factorial is equal to n into n minus 1 factorial. And in the denominator we get n minus r factorial, that is equal to 6. Now dear students, in the numerator r minus 1 factorial, denominator r minus 1 factorial got cancelled. In the numerator n minus r factorial and denominator n minus r factorial got cancelled. So what we get? N minus r plus 1. So we get from here n minus r plus 1 is equal to 6 into r. Correct dear students? So from here what we get dear students? So from here we can write that 7r is equal to n plus 1, and that implies r is equal to n plus 1 by 7. Correct? So let me write here. Okay. So what we get here, r is equal to n plus 1 by 7, and let's give this as equation 2. Now dear students, if you look at that in the both equation 1 and 2, the value of r is expressed in terms of n. So what we can say from 1 and 2? We can say that n plus 9 by 8 is equal to n plus 1 by 7, and that will give us the value of n, which is the question has been asked in this one. So what I am saying dear students, so from these two, what I can say, that is n plus 9 by 8, n plus 9 by 8 is equal to n plus 1 by 7. Now if we cross multiply, what we get? This into this, 8n plus 8 is equal to 7n plus 63. So that implies this 7n we bring in this side, so it is n, and 8 into that side is equal to 55. So we get the value of n as 55, and we are done with this question. So with this note, let me conclude the session here. In the next session, we will solve some little bit advanced question, little bit advanced, not too advanced, little bit advanced question. And take care. Thank you very much. Bye.